So today I want to talk about prime numbers again. I'm going to remind you, prime numbers are numbers that cannot be split into smaller factors. So for example, I shouldn't write 9 here in the list of prime numbers because 9 can be written as 3 times 3, but 11 and 13 are okay. 15 doesn't work, but 17 works, 19, not 21 because that's 7 times 3, 23 is okay, and so on. And today what I want to show is the very old fact that there are infinitely many prime numbers. So this list never stops. It keeps going on and on. You can always find bigger and bigger prime numbers. Now how can we show that? Suppose not. In other words, I'm going to do a proof by contradiction. Let P be the highest prime number. So if there aren't infinitely many prime numbers, then there must be a last one. And I'm saying, let's suppose that there is a last prime number, P, the highest prime number. Now I want to do something which is going to allow me to build a prime number which is even bigger than P. And the way that I'm going to do that is I'm going to consider P times P minus 1 times P minus 2 times, and keep going until I get to 3 and 2 and 1. And I want to consider the product of all these numbers put together. So if P was 23, then this would be 23 times 22 times 21, all the way to times 3 times 2. So this is sometimes written P with an exclamation mark and called P factorial. And this is a pretty big number. We're multiplying a lot of numbers together. It gets big very quickly. Now it's clear that P factorial has lots of factors. In fact, it has each of these numbers as a factor by construction. That's how I built it. It's also clear that P factorial plus 1 has no factor less than P plus 1. Because if I take this number, which is the product of all these numbers, P factorial, and I add 1 to it, suddenly none of these numbers evenly divide it anymore. So by adding 1 to P factorial, I've constructed a number which doesn't have any of these guys as factors, right? Except for 1. Of course, every number has 1 as a factor. How is this going to help me? Well, if P factorial plus 1 was prime, then I would be done, because I would have found a prime number which is definitely bigger than P, which was supposed to be the highest prime number. But I don't know if P factorial plus 1 is prime. But I do know that whatever this number is, P factorial plus 1 can be written as a product of prime numbers. That's because every number can be written as a product of prime numbers. So this number can be written as a product of prime numbers. What prime numbers are in that expression? Well, it can't be any number which is in this list from 2 to P, because none of these numbers are factors of P factorial plus 1. So whatever numbers are the prime factors of P factorial plus 1, they have to be prime numbers which are not in this list and therefore bigger than P. So I haven't shown you exactly which prime number is bigger than P, but I've proven that there must be at least one prime number bigger than P, and so there can't be a highest prime number.